while back I managed to screw up my 4mm collet while drilling a pellet hole. I had the drill bit sticking out too much and perhaps not clamped down enough, so when the drill got stuck inside the workpiece, the collet spun around the drill bit and basically had it for dinner. Everything galled up inside here, and much of the drill here got eaten away. I'll add it in a picture. Now these here are non-standard collets. No idea what they are, so replacing one of them will be hard to do. So I asked Banggood if I could do a review video of one of their collet sets. They agreed, and there was much rejoicing. So here it is, my new Banggood collet set. Ta-da! This here is an almost complete set of er32 collets. There's a 1 to 14, a 16, an 18 and a 20. So the smallest one is missing and some of the bigger ones. I doubt I will ever miss them. The collet chuck here is an MT3 one. It will fit inside my old lathe. And there is a hook spanner. All inside a nice sturdy case that survived the long journey from the east to my little tool temple over here. I must say that the collet chuck is a bit loose in its pocket here. They probably use the same case for other chucks. I don't think the chuck got damaged, but we will find out. I like a case like this. It's good storage, and it protects the collets from collecting dust. But if you buy the content inside the case individually, you will save about €10 and gain 4 extra collets. I find this a bit strange because usually things get cheaper if you buy a package deal. So if you fancy building a dust collecting collet rack for next to the lathe, you should forget about the case and save yourself some money. I will unwrap things now and do a little visual inspection. Well, I got everything unpacked. There was some oil in the plastic bags. You can still see this here, to prevent things from rusting. I did my visual inspection, and at first this looks like a very nice set till you start noticing the cosmetic problems. I found some of these chips in quite a few of the collets. They're from the well, they're probably from the slitting saw. I still need to check them all again. A pretty annoying job to do. Another thing I noticed was these I think it was this one. Yeah, this one here. These slits are not evenly spaced. It's wider over here than it is over here. It almost looks like they restarted the slit cutting operation. This collet over here, this one is just bad. It is not properly ground. It is sharp. There are some dings or nicks. Well, you won't cut yourself, but it definitely catches your skin. Listen to this. I'm not sure how good the camera picks that up, but that's quite a difference. Some of these collets have small nicks, dents in them, and it makes you wonder how those got there. Here's an example. The collet looks very pretty, but then there is a small nick there. Looks like it got touched with the slitting saw. It probably won't affect the precision, but still, it makes you wonder what happened. Alright, moving on to the collet chuck. It looks pretty decent. There's some machine marks here. There are a few burrs inside here, but nothing to worry about. You can still see some machine marks there, like it hasn't been ground down far enough. You can hear it catch my nail. That shouldn't be there. And the front face here, it has the well, it looks like a bandsaw finish, but that shouldn't matter. It says MTB3. I wonder what that extra B stands for. Mountain bike? I don't know. er32 M12. The thread on here is very nice and very smooth. And then there is the spanner. What can I say about this thing? It fits. It looks like the overmolding filled in the hole here. So if you want to hang it on the board, you will need to redrill that hole. Alright, I think we should test for a run out. Before I start testing the collet chuck, I need to know the run out of my spindle, so I can deduct that from the total run out, and that way I can calculate the chuck run out. The dial seems to be a bit jumpy, but I think there is about 0.02 of a millimeter run out. I will now try to mark the high spot on the spindle. I think the high spot is somewhere around here. I've installed the collet chuck, and now I'm going to test the outside diameter. The run out should be about the same as on the spindle, and the high spot should be more or less on the same location, but that depends on how well I mark the high spot. Well, that looks close enough for me. The high spot might be a bit off, but that's probably my fault. Run out seems to be the same. Alright, now I'm going to test the inside. Maybe I should invest some Banggood commission points into one of those cheap test indicators they sell, because this is an annoying thing to set up. Besides, I am introducing a measurement error by having the dial indicator at an angle. It's small, but still. I'm hitting the side of the collet chuck. Okay, that's about 0.03 of a millimeter. That's not too bad. 1/100th more than the outside. Now let's see if we can repeat this. 90 degrees. Tighten up the drawbar. Here we go again. Oh, that's pretty bad. Looks like at the first test the inside runout was offset against the runout of the spindle. Let's mark up the high spot for the internal diameter of the collet chuck. I bet it's pretty much aligned with the high spot of the spindle. Maybe a bit offset. I would say that is about 0.08 of a millimeter. So if I deduct the spindle runout, I end up with 0.06 of a millimeter runout, and that's a lot for a collet chuck. Even a half decent 3-jaw scroll chuck should be able to do that. It's a good thing I have another collet chuck that I can use to continue my testing, because this one here, this one is pretty bad. This second collet chuck I've got fits the tailstock of my lathe, and it is replacing the collet chuck that I made myself for my flea market collet set. Damn gravity. Well oiled, smooth thread, maybe a bit rough on the inside. The same bandsaw marks on the face of the chuck, also a few little burrs in the end. The Morse taper seems to have been ground a little deeper. No machining marks visible anymore. Alright, let's test it out using that adapter sleeve I modified a few videos ago. It's the next week, well actually it's the next year, so Happy New Year. I did some testing with that modified adapter sleeve, but the results I got made me doubt about that thing. So I ordered a new sleeve, and it arrived today. It's not a Banggood adapter sleeve. That would have taken too long to get here. But I can't use the drawbar with this one. Let's see what we got. That's not bad. Let's mark the high spot, see if it lines up with the high spot on the spindle. It's about there. So it doesn't line up. So let's line up the high spots and check the runout again. That's almost perfect in my book. I wasn't expecting that. Anyway, let's continue testing that MT2 collet chuck. That's not too bad. The high spot doesn't really match up with the high spot on the spindle, but there's not much run out. Let's test the inside. Looks like the same problem as with the other collet chuck. The inside of the chuck just isn't concentric with the outside. That's about 8 or 9 hundredths run out. This is starting to look like a Monday morning product. As a reference, here's a shot of the old collet chuck, and the run out I'm measuring inside the collet chuck is about the same as the run out on the spindle. So that proves that the inside of this collet chuck is pretty much concentric with the outside. You know, here's a thing that's a bit annoying. With a collet set you get a nice hook spanner to lock up the collet nut, but you don't get a spanner to use on these flats here. And I don't have a let's see, 35mm spanner, but I do have a big crescent wrench, but unfortunately that won't fit. The flats are too narrow and I'm hitting the spindle. Now if your lathe has a spindle lock you could use that, but you do risk breaking the taper loose. Fortunately I've got this big bicycle bottom bracket tool and it fits more or less. It's a bit too big, but it will do for now. So here's a tip for all those collet set manufacturers: make those flats a little wider or supply a spanner. It's time to test a couple of collets, and I've selected these three basically because I have some stock material that fits. There's a 16, 10 and a 5. I think these three should be representative for the rest of them. The 10mm was the worst looking collet of the bunch. The 5 looks pretty good, and the 16 also looks pretty decent. I've checked them for chips using this ruler, and I just wanted to show you that this number 10 is pretty bad. It doesn't go any further down. I will be using the MT3 collet chuck to test the collets. I lined up the high spot, and at the moment I have about 0.07 of a millimeter run out. I'm using a bit of WD-40, that way the tapers will slide a little easier. Tighten it up really good. I'm planning to test every collet twice, so I will take out the stock material, reposition everything, and tighten it up again. Alright, first test. Oi, 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 oi. That is 27, 28. That's horrible. I'll set it up for a second test. That looks better, but still at least 1/1600, maybe 1/1700 of a millimeter run out. So that's still pretty bad. So this is test number 3, and it looks a bit better than test number 2. Maybe this is 1400ths of a millimeter runout. This is the first test for the 10mm collet, and remember that was the worst looking of them all. That's about 1400ths of a millimeter runout. Here's the second test. It's a little better, about 1/10 runout. Test number 3, and we are back at more or less 1400ths of a millimeter runout. This is the third collet I was going to test, the 5mm one. I got here a piece of tool steel, and it's 497mm. That's pretty close to 5mm. Now look at this. That's a bit more than 300ths. This is not really an accurate measurement, but about 5.5mm. That's pretty far off from the 5mm it should be. First test for the 5.5mm collet. That is actually one of the nicest looking ones. Let's see how good it compresses down to 5mm. Not great. That's about 22/100ths of a millimeter. Test number 2, and that's about 16/100ths of a millimeter runout. And here's test number 3. Looks like the runout got offset against the spindle and chuck runout. Alright, time to wrap it up. Here's my conclusion. This set here is bad. There's no other word for it other than real bad. This one is bad as well. Many machining errors, lots of runout. I don't know where Banggood buys their collets at, but they really should have a talk with their supplier about quality control. This set just shouldn't have been sold. Testing these was depressing and a huge disappointment. And now I have to watch it all again while editing this video. Great. Well, that's it for me. To be continued. As if you need any more proof that this is a bad collet set, but check this out. This is the 16mm collet I tested before, and it measures about 32.6, and it fits fine. Now this one here, the 13mm collet, it measures 33 and a bit. Junk!